All right. Simplifying non-perfect square radicals. All right, let's go right here first, okay? All right, what you are seeing on the screen right now, these are things that hopefully you are familiar with, okay? Those are technically what we call radical symbols, okay? We often refer to those as square roots. But guys, there's such things as cube roots and fourth roots and fifth roots, but those are radical symbols, okay? The numbers underneath those symbols right now are perfect square numbers, okay? These are numbers that result from a number times itself, okay? And again, I'm going to assume a little bit. If I said, what is the square root of 9? Most of us would then say 3. That is correct. The square root of 9 is 3. Where does 9 come from? 3 times 3. Okay? The square root of 36 would be 6. The square root of 121 would be 11. Okay? So again, these are things that I think you are familiar with and you have had some experience with. One of the things, and I will provide it for you on the worksheet today, but is just being familiar with perfect square numbers, okay? And for a lot of these numbers, I think you are familiar, all right? Everybody okay with this so far? Everybody good? Any questions? All right. So, what do we do? What do we do with a radical if it's a non-perfect square number? How do we do this, okay? And guys, sometimes, and it kind of depends on the application, it kind of depends on what the directions are telling you to do, but is a decimal answer okay for some things? Sure, okay? But sometimes they want you to leave the answer in what we call a radical format, okay? And this would be, what we're getting ready to do is kind of the equivalent of reducing a fraction, okay? If you have a fraction that's reducible, you're expected to reduce it. If you get 8 over 16, you guys need to make that 1/2, okay? If we get some of these radicals and we are able to simplify them, then you are expected to do so, okay? So, let me move this out of the way. Those perfect square numbers right there, all right? Now, you can jot those down if you want. They're going to be on your worksheet for today. But those are pretty much the first 15 perfect square numbers, okay? We need to be familiar with these, all right? And again, where does this list come from? A number times itself. 2 times 2, 4. 3 times 3, 9. 4 times 4, 5 times 5, 6 times 6. Right on down the list, okay? So this isn't necessarily a list that you need to memorize, okay? I think you just need to understand where that comes from. Okay, and then you could actually generate this list on your own if need be, okay? But we do need to be familiar with these numbers and recognize them, all right? We kind of dealt with these with factoring a little bit. Difference of 2 perfect squares. We kind of dabbled with perfect square numbers there. So we're going to get another dose of these, okay? So with that said, let's say that we get the square root of 8, okay? 8 is not on that list. 8 is not a perfect square number. If you punch that into your calculator, you're going to get 2 point something, 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 and it's going to go on forever. And you're going to kind of go, God, what do we do? All right. Well, we want an exact answer for this. We want to reduce this. We want to simplify it. All right. Okay, here's the deal. Guys, as soon as you recognize that you have a non-perfect square value underneath that radical, we're going to put an equal sign, and you're going to draw 2 radicals there, just like I've done there, okay? And those 2 radicals are technically being multiplied together, but we're going to get 2 radicals. The first radical is what I call my perfect square radical, okay? The first radical is what I call my perfect square radical, hence the PS. The second radical is what I call my leftover radical, okay? And so what we're going to attempt to do here is we want to rewrite 8 using a perfect square number, Okay? Guys, if you look at that list, is there a perfect square number on that list that will go into 8 evenly? 4, of course. And 4 times what is 8? So here's what we're going to do. We are going to rewrite the square root of 8 as the square root of 4 times the square root of 2. Those two things are the same. They are equivalent. Okay? But in doing so, because now I have a perfect square number involved, can we take the square root of 4? What is the square root of 4? Square root of 4 is 2. And I put my leftover root 2 behind it. So our whole goal here is hopefully we can find a perfect square number that we can rewrite these numbers with, so I can take a square root. I rewrite the square root of 8 as the square root of 4 times the square root of 2. I can then take the square root of the 4, which is my 2 here. And guys, once you take the square root of something, the radical symbol is gone. Okay? The square root of 4, 2. The square root of 2, I can't do anything with. That's my leftover. I put it right behind there. 2 root 2 is equivalent to the square root of 8. And if you take 2 times the square root of 2, you would find that it is the same value as the square root of 8. 2 point something, 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 something. But now we've got an exact answer. We don't have to worry about rounding decimals off. This is exact. This is a simplified answer in a radical format. Okay? Everybody okay with that? Any questions there about the first example? Okay? So again, a lot of this is going to be recognition. Okay? Take a look at the next one. All right? Square root of 27. Square root of 27. Is 27 a perfect square number? Is it on the list? It is not. As soon as we recognize that we have a number that's not a perfect square, we're going to get 2 radicals going. And you don't have to label them. I'm doing that kind of for visual purposes to kind of reinforce what those radicals are going to represent. The first radical, again, is what I call my perfect square radical. Anything I put in that radical, I want it to be a perfect square. The second radical is just going to be my leftover stuff. And my leftover stuff, I can't do anything with it. Okay? That's why it's leftovers. What's the largest number on that list, on that perfect square number list that will go into 27 evenly? 9. 9 times what? 9 times 3. And that's kind of the nice thing about this, guys. You have a list of numbers that's, actually that list goes on forever, but really it's a limited amount of numbers. You have a list of numbers that you get to reference and go, I need one of these numbers to work, okay? And in this case, it's 9 times 3. I rewrote root 27. Guys, what is the square root of 9? 3. Leftover root 3 behind it. 3 root 3 is the same thing as the square root of 27. Okay? Now, coincidentally, these are not all going to work out to where you've got the same number outside and inside the radical. This is a little bit of a coincidence, which is fine. But so I don't want you to think, oh, it's always got to look that way. Okay? All right, so far so good? Everybody good? Does everybody have what they need off this slide? Okay, let's keep going. Now, as you start to see some of these numbers, you'll kind of learn what works best for them, okay? Let's go ahead and work with square root of 48. Is 48 on the list? It's not on the list. 2 radicals. Now, listen carefully. Okay, listen carefully. It's kind of like greatest common factor. Okay, when we did all that factoring, I always said, look for the greatest common factor first. Get it early because I'm afraid if you don't, you might miss it later, okay? When you start breaking these radicals down, it's going to be important that you try to grab the largest perfect square number that goes into a given number. So, what's the largest perfect square number that goes into 48? 16. Okay? Now, there's going to be a lot of people that might, kind of a knee-jerk and kind of go, oh, well, 4 times 12 is 48. Well, that works. Okay? And I'll show you what happens here in just a second. But 16 is the largest perfect square number that goes into 48. If you are not sure what works, this is what I would do. I would grab a calculator, and you're sitting there going, well, I don't know what works for 48. I would grab a calculator, and I would start high on that list. Okay? I would start with 36. And you go 48 on your calculator. 48 divided by 36. Nope, doesn't work. 48 divided by 25. Nope, doesn't work. 48 divided by 16. Boom, 3. And you go, oh, it's 16. The best, most efficient way to break down 48 is 16 and 3. What's the square root of 16? 4. The square root of 16 becomes 4. I put my leftover root 3 behind it, and I'm simplified. 4 root 3. 4 root 3 is the simplified version of root 48. Now, what happens? What happens if I go 4 and 12? 4 times 12 is 48. 4 is a perfect square number. Okay, so again, we're going to have people that are going to look at this and go, hey, this works. So what's up? Well, what's the square root of 4? 2. So we'll have some people that might go 4 and 12 for 48. Everything's working. I take the square root of 4, I get a 2, and I go 2 root 12. So what's the problem? Well, the problem is this. That number underneath that leftover radical 12. Is there a perfect square number that will also go into 12? What? Well, it's got to be on that list. 4. 12 contains a perfect square factor of 4. So really what you would be required to do is you have to break down the 12 again. And so you would still have this 2. We would then have to break down the 12 into 4 and 3. And what's the square root of 4 again? 2. And so root 4 times root 3 becomes 2 root 3. And then these 2's multiplied together here become 4. Now take a look at that. We get the same answer, but that road to that answer is a little bit longer. Okay? And so I really, really emphasize, just like with greatest common factor, when you guys break these radicals down, really, really try to grab the largest perfect square number that's going to work. Otherwise, I'm afraid that we're going to just, and guys, it's an experience thing. You guys probably haven't done enough of these to recognize, hey, root 12 can be broke down again. Now I've got to do it again. And now I've got to stay organized in this work. This is a little more work. Get the largest one in the beginning, and you ought to be in real good shape. Okay? But that's what happens if we don't grab the largest perfect square number that works. Okay? Let's go to the next one. Let's go to root 80. Let's go to root 80. Well, 80's not on the list, is it? Obviously, 80's not on the list. So we're going to get our 2 radicals going here. And again, if you're not sure, grab a calculator, start dividing. I would start high and work low on that list. For 80, I would start with 64. 80 divided by 64, 80 divided by 49, 80 divided by 36, nope. 80 divided by 25, nope. 80 divided by 16, 5. Guys, the largest perfect square number that works for 80 is 16. 16 and 5. Again, there's going to be a lot of people that might think, oh, 4 and 20. 4 is a perfect square number. 4 and 20. But 20 also contains a perfect square factor of 4. You'd have to break the 20 down again. Try to grab the largest perfect square number that you can. You've got a list right in front of you that you see, and you know what numbers you can start working with. Square root of 16? 4 root 5. 4 root 5 is the simplified form of root 80. And so like I said, once you start seeing some of these numbers enough, you see 48, you learn 16 works. 80, 16 works. 72, it's 36. Okay? Last one on this screen here is root 75. 75 is not a perfect square number, so we're going to get our two radicals going here. Guys, what's the largest perfect square number that goes into 75? 25 times what? 25 times 3, good. 25 times 3, so we rewrite it. And then the square root of 25? This is going to become 5 root 3. 5 root 3. Please, 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 please remember, when you take the square root of something, that radical symbol disappears. Okay? Take the square root of 25, 5. The square root of 3. Guys, if we do the leftovers right, you guys shouldn't be able to do anything with those leftovers. Whatever's under that leftover radical, 3, I can't do anything with it. Stays root 3. 5 root 3 is an exact answer. Okay? That's leaving your answer in a radical format. Okay? What do you think? Guys, that's it. But this is one of those skills wherever radicals are involved, this can kind of show up. And again, depending on the instructions, depending on the application, you may need to leave your answers in a radical format. So this is kind of one of those fundamental skills we need to be able to do when we recognize what we've got. Okay? All right? Okay.